right, good morning, everyone. We're doing section 6.2 today. 6.2 is called factoring polynomials. I really would rather we kind of think of it more as just learning about how to write polynomials in factored form and then move from factored form into their general form. But anyway, but the name of this lesson is called factoring polynomials. We're in section 6.2. So we're going to start by doing a little bit of an investigation. We're going to start with a cube. When you start with a cube, all the sides have the same length. So if I call my width x, then my length has to be x and my height has to be x. So volume of a cube, if we were just to do a traditional cube, it would be length times width times height, x times x times x, or x cubed. Volume of a cube is the side cubed. We're going to do something a little different though. We're going to increase the height by 2, the width by 3, and the length by 4. This now is no longer a cube, it's a rectangular prism, but let's see what happens when we do that. So if we increase the height by 3 or by 2, the height is no longer x, the height is now whatever it was, x plus 2. So our height is the original x plus 2. Our width, if we increase the width by 3, our width is no longer x, it's x plus 3. And our length, if we increase the length by 4, our length is no longer x, it is x plus 4. So the volume of this new box that we have created is x plus 2 times x plus 3 times x plus 4. X can represent the length of any original cube, and now if we expand the height, the width, and the length, we end up with a new function. So if I were to express this form right here is called factored form. Why is it called factored form? Because it's all written as a product of factors. Remember, when you have something times something times something, each of these things are called factors. Now, if we multiply these factors together, I'm going to multiply just the first two. So if I multiply the first two factors together, I get x squared plus 3x plus 2x plus 6. And then I still have this little x plus 4 kind of coming along. So I end up with x squared plus 5x plus 6 times my x plus 4. So I'm starting to expand. I'm not quite there yet. That's a squared in case you can't see it. All right, so now if I have to multiply this times this, a trinomial times a binomial, first I'm going to multiply x squared times both of these terms. So I get x cubed plus 4x squared. Then I'm going to multiply 5x times both of these terms. So I have plus 5x squared plus 20x, and I'm going to run out of space, that's okay, plus 6 times both of these terms, so plus 6x plus 24. And if I combine my like terms, then my final expanded polynomial is x cubed plus 9x squared plus 26x plus 24. Now, if you notice, your x cubed, that's x times x times x. So I knew this was what kind of a function is this? It's cubic because the highest degree is 3. We have an x cubed. I could tell from my factored form it was cubic by counting the x's in all of my factors. So I have 1, 2, 3 x's. That means that this is a cubic function. Without seeing the degree in front of me, I know by counting the x's, there are 3, it's a cubic. You can also find your constant term by just multiplying the numbers together. 2 times 3 times 4 equals 24. But you can't find these middle terms without actually going through the process of expanding it all out. And so that's our expanded form. All right, so that's us just rewriting it again. So this third degree polynomial, we already learned this yesterday. This is called a cubic function. So we have two forms. We have factored, which is hard to write on here, factored, and we have expanded, which is also called general. So the cubic function, both of these, if we were to put these into a calculator or Desmos and graph them, we would get the exact same graph for both of these. They're equal to each other. So they are both equivalent, just different forms of the same thing. All right, so factored form, the roots and the x-intercepts, so the root, I don't know, we're saying roots and x-intercepts. We're kind of talking about roots. Okay. Of a factored form are of a polynomial all inform you about the short run behavior of the polynomial. When we say roots or x-intercepts, I kind of use them interchangeably. So forgive me if you hear me use one time and another time. But the roots or x-intercepts are these points where the graph intersects the x-axis. So these would be your roots or your x-intercepts. The other point that is also important in knowing your function is the y-intercept. So we're going to use all of these, the x-intercepts and the y-intercepts, in order to figure out our function. All right, where's my picture? I'm going to pause recording and see if I can get this slide. This is what I was going for. So we're going to write the cubic functions for each of these graphs. So for this, when you are writing your cubic function, what's wonderful is the x-intercepts actually lead you to the factors. They're kind of the factors written backwards. So if I rewrite this function, I have some unknown constant in front, and then I'm going to do x minus each of my x-intercepts. So this is x minus negative 2.5, so I'm going to write plus 2.5. And then x minus 3.2 and x minus 7.5. And the only other thing that I need to find is this a value out front. So I've got my factors, life is good, but I need to find this coefficient that goes in front, and that's where I use my y-intercept. So when x is 0, y is 240. So I say 240 equals a times, let all your x's become 0, 2.5 times negative 3.2 times negative 7.5. And if you multiply all those together and solve for a, which I need to get my calculator. Here we go. So I get 2.5 times 3.2 times 7.5. So I get 240 equals 60 times a, because negative times a negative becomes a positive. So if I divide by 60, I get a equals 4. So then my final answer is y equals 4 times x plus 2.5 times x minus 3.2 times x minus 7.5. Let's do another one. So for this one, let me erase this line that's just sitting here in the middle. There we go. All right. For this one, we have the exact same x-intercepts. So we still start with y equals a times x plus 2.5 times x minus 3.2 times x minus 7.5. The only difference is this a value. And how do we know it's different? Because we have a different y-intercept. So now we have the intercept 0, negative 90. So I set my y equal to negative 90. And I set all my x's equal to 0. So 2.5 times negative 3.2 times negative 7.5. And so I have negative 90 equals 60 times a. If I divide by 60 and reduce my fraction, I get a equals -3/2. That's a 2. So my final equation is y equals -3/2 times x plus 2.5 times x minus 3.2 times x minus 7.5. That is a 7 there. So these, the x-intercepts, those give you your factors. Those give you your factors. And then the y-intercept, this is what gives you your what's called your leading coefficient, or your a value. Okay, so the graph of each function here, we're going to use the graph of each of these functions to find their factored form. And so we're going to start with x squared minus x minus 2. I have these graphs on the next, no, I don't. Oh, good. Okay, I'm just going to use Desmos in order to graph these functions. So we're starting with x squared minus x minus 2. I'm going to go over to Desmos, and let's see if I can type, so y equals x, this might take a little bit. Where's my caret? Whoops, I don't want that. I wonder if it'll just let me write. Y equals, here we go. So first let's delete that. Equals, no, it's not liking that. All right, well, we're back to x. X. And maybe if I go, hey, there we go. Okay, so back up. Okay. X squared. Oh my gosh, this is taking forever. I'm sorry. We'll get this eventually. Let's see. Now I got to find what I'm doing. X squared minus x minus 2. X squared. Okay. Minus x minus 2. Where did it go? We got it. Okay. Sorry, that took some work. Whoops. Go away. There we go. Okay, so if we look at our x-intercepts, sorry that took so long, but we'll get it better next time. So our x-intercepts, we have here an intercept at -1, and then we have an intercept at x equals 2. So we have those two intercepts, -1, 0, and 2, 0, which means our factors would be the opposite sign. So x plus 1, x minus 2. So going back to our Schoology, or not our Schoology, but our, there we go. I'm going to move this up, give myself some space. So for A, we have y equals x plus 1, x minus 2. Now, I know you could have factored this by hand and obtained the same factors, but this one might be a little bit harder to factor by hand. Now, it can be done. If you know how to factor by grouping, it can be done. All right, let's see if I can type this in without messing it up. 4x cubed plus 8x squared. So here we go. So back. All right, 4x stop it, 4x cubed, there we go, all right, 0. Okay. Plus 8x squared x. Okay. Okay, 4x cubed plus 8x squared minus 36x minus 72. All right. Minus 36. No, it's not like in the writing. I want my keyboard. X minus 72. All right, well, we got it. Okay, so let's take a look at our intercepts. We have an x-intercept at negative 3, 0, an x-intercept at negative 2, 0, and an x-intercept at 3, 0. So from the intercepts, we can write the factors x plus 3, x plus 2, x minus 3. Now we're not done, but that's at least a start. So we have y equals a times x plus 3, x minus, plus 2, x minus 3. I think I wrote those down right. Yep, plus 3, plus 2, minus 3. Now, on the last one, what I forgot to point out to you was I didn't actually put an a in front, but that's because there was no coefficient. I knew that the coefficient was 1, so I could stop right there. Here, you can, well, let's see. I'm going to show you how to do it algebraically, and then I'm going to show you kind of the shortcut way if you want to write this in factored form. This actually is your leading coefficient. So your a is actually going to become a 4. If we want to do it using the way that we have done it in the past, so I'm going to see if I can zoom out. Here we go. Let's zoom in a little. I'm looking at this y-intercept here. So let's see if it's at 72. Yep, it's at 0, negative 72. So if we did it by hand and we set our negative 72 equal to our a times 3 times 2 times negative 3. This is like the worst handwriting in the world. There we go. So we get negative 72 equals negative, let's see, 9 times 2, negative 18a. And if you divide out, you're going to get a equals 4, which is the same thing as the coefficient here. So you can do, like, just letting you know that you can go ahead and just bring that down. So our final equation is 4x plus 3, x plus 2, x minus 3. All right. All right, so once you know the zeros of a polynomial, so they're calling these r sub 1, r sub 2, r sub 3. So those are your zeros. Zeros, remember, are the same thing as x-intercepts. And you can write it like that. All right, you can also write a polynomial function in factored form when the zeros are not integers, or even when they are non-real, which we'll get into in a little bit. Okay. So for this first one, these were supposed to be covered up, but these are just actually the graphs of what we just did. So this is just showing you this first one. We had an x-intercept here and here, so we could write our factors x plus 1, x minus 2. Remember, you change the sign to the opposite sign. And then same thing here for, I got a 3 there. Wait, am I wrong? Let's see. Did I use the wrong number? No, I think this answer key is wrong. Ooh, it takes us a while to get out. Whoop. Yeah, it was definitely a 3. So there's just a little mistake on this. This should be a 3. There we go. Okay. All right, more practice. Find the zeros of the function below and then write the polynomial in factored form. So we're going to try this again. X cubed minus 4x squared plus x minus 6. Let's see what we got. So, let's see if I can do it this way. Nope, it doesn't like that. Okay, x cubed. All right, now I've forgotten already. Minus 4x squared plus x plus 6. All right, minus 4x squared. Okay, plus x plus, come on, 6. All right, so there we go. X cubed minus 4x squared plus x plus 6. So you want to first look at those x-intercepts. So we have one at -1, one at 2, and one at 3. So our factors would be x plus 1, x minus 2, x minus 3. So we would have, we're going to call this, use function notation, x plus 1, x minus 2, x minus 3. And what is our coefficient? Since the coefficient here is just 1, it just goes down there as a 1. You don't have to change anything, and you don't even have to recalculate. You just bring it down. All right, just a little review of quadratics. If you have real coefficients, that doesn't mean you have to have real roots. So for example, x squared minus x plus 1 looks like a nice happy polynomial, but there are no x-intercepts at all. All of the x-intercepts, all of the roots are complex. Here, very similar. The only thing that changed was a negative, and now we have 2 real roots. Okay, again, they don't have to be integers, not integers, that's okay. So if we had, by the way, if you have non-real roots or if you have non-integer roots, the easiest way to find those roots is to use the quadratic formula. And then, of course, if you have 2 real integer roots, then factoring is always fastest. That's why we say factoring is our friend. Yay, factoring. Okay. All right, so quick review, and then we're done with this lesson. Without graphing, find the x-intercepts and the y-intercepts for that graph. So for number 1, the x-intercepts would be, remember you change the sign, so be 2, 0, and let's write them as ordered pairs, -1, 0, and 3. That's a 3, 0. So to find the y-intercept, set your x equal to 0. So let's go, we'd have -4 times -2 times 1 times -3. So we end up with -24. So our y-intercept would be 0, -24. All right. Number 2, to convert the polynomial to general form, I'm going to erase number 1. So if you need it, you know what? Maybe I need to just add a page. Let's go ahead and just add a page. -x times x plus 1 times x minus 5. All right, so all you have to do is distribute. So I'm going to distribute the binomials first. So x squared minus 5x plus x minus 5. So if we combine like terms, we get x squared minus 4x minus 5. And then now you're distributing this negative x in. So we end up with -x cubed plus 4x squared plus 5x. And there's your final answer for that one. All right, and then finally, if we expand x minus 1 times x minus 2 times x minus 3, so x minus 1 times x minus 2 times x minus 3. X minus 1, x minus 2, x minus 3. So if we multiply the first two together first, x squared minus 2x minus x plus 2. I always like to combine like terms first, just to make my life a little easier. X squared minus 3x plus 2. And now you're going to multiply this guy by both of these, and then the next term by both, and then the last term by both. So you get x cubed minus 3x squared, then this guy times both of these. So minus 3x squared plus 9x, and then your last term times both of these. So plus 2x minus 6. And when you combine, you get x cubed minus 6x squared plus 11x minus 6. And there's your polynomial. All right, we have one more page. This is our last page for this lesson. How many roots does this polynomial have? Well, technically, it has 2 roots. So it has the roots 1, 0, and negative 2, 0. So technically, it has 2 roots, except one, this guy right here is a repeated root. So one of them has what's called a multiplicity. Multiplicity of 2, because it's really like this factor is repeated. When you have x minus 1 times x plus 2 times x plus 2. So even though it's the same root, so technically we only have 2 roots, this guy's repeated. So we say that it has a multiplicity of 2 because it's repeated twice. What happens when the graph of the quadratic has exactly 1 point of intersection with the x-axis? When the graph has exactly 1 point of intersection with the x-axis, let's just say this is at x equals 3, then your equation, that 3 becomes a repeated root. It's your only root, and it gets repeated twice. So we would have x minus 3 squared, or x minus 3 times x minus 3. So you end up with a repeated root. And here ends the lesson. Have a great day.